Hi guys, this is Jerry Pinter, your instructor for EE 330. I've been teaching at Cal State San Marcos for 20 years now, and I've never had to miss a single class for being sick. So I can't tell you how disappointed I am to not be in the classroom today. But I came down with some bug while I was traveling home at the end of summer from vacation, and I didn't want to risk getting you guys sick, so we're going to start the class out the asynchronous way with some video lectures that I've prepared. This way we can stay on schedule, and I hope to be back in class really soon so I can meet all you guys in person. So please sit back and enjoy this first introduction to our course, and if necessary also I will prepare a couple of video lectures on the first chapter as well. Let's get started. Thank you. Hello again. This is your instructor, Mr. Jerry Pinter, and welcome to EE 330 Electronic Circuits. In this short video, I will introduce the course to you. So you've already met me in my short video introduction. Let me just give you a brief background of myself. I'm an electrical engineer like you guys. I studied at the University of Illinois for undergraduate and went to UC San Diego for grad school. I spent 17 years in the semiconductor industry working on research, development, and manufacturing of semiconductor integrated circuits. I worked for a couple of companies here in the local San Diego area. I worked for a Hughes Technology Center, which was a defense contractor in Carlsbad, and then I worked for Applied Microcircuits Corporation in San Diego, where and that was, by the way, a telecommunications company, and I retired in 2002. And so for the past 20 years, I've been teaching part-time here at Cal State San Marcos. I started out teaching physics and astronomy. Astronomy is one of my hobbies. You can see me in this picture here with one of the telescopes that I've built. And then most recently, the last few years, I'm proud to say I'm teaching electrical engineering now. So what I'm going to do in this video is just give you some highlights from the syllabus for the course. The full syllabus is, of course, located on our Canvas site, which I'm sure you're already familiar with. That Canvas site also includes all of the lecture notes, the syllabus, and the homework and the labs and the schedule and so forth is all found on Canvas. So please get yourself familiar with everything on Canvas. One thing I will mention also again is that the full lecture notes are available on Canvas. So what this means is during lecture, you don't have to be copying down everything that I'm showing and talking about. You have all those notes on file here in Canvas. So you can still take some notes during class. That's always a good idea, but you certainly don't have to copy down all the stuff that's up on the screen because it's available on Canvas. My email is here, which you're probably already familiar with. We have a couple of student lab assistants that will be helping us. Some of you may know these students. Jonathan Nunez and Christopher Lee will be helping out with during some of the lab sessions and also during some of the open lab sessions, which I will explain shortly. My office hours currently are Monday and Wednesday after class. I believe our lab classroom, Visat Engineering Pavilion 5109, is available. I don't think there's another class after ours, so we can just stay right in class. If you have any questions, just come on up and ask me then. If we need to, I also have a shared office in the other building, VEP 6, Office 19, which is the adjunct faculty office. The textbook we're using is a university standard. In fact, I used this book 40 years ago at the University of Illinois, Cedar and Smith Microelectronic Circuits. I actually used the first edition when it came out back then. And it's now, I think, on maybe the 10th edition or even 11th edition. We're going to use the 8th edition. Now, you don't have to buy a brand new textbook, which will cost you, north of $200 probably. You're welcome to if you want to. You can find them much cheaper. For example, you can get paperback versions for less than $100 on Amazon. What I would really recommend if you want to save some money is pick up an older used edition. For example, the 5th edition is just fine for this course, for your reading outside of class. And I've seen them for as little as $8 on Amazon. So you might have to shop around a little bit there, but hopefully you can find some version of the textbook so that you'll have that as a resource for the class. So the course description, we're going to be studying the properties and physics of semiconductor materials and devices. And the devices that we're going to be looking at are diodes, bipolar junction transistors, or BJTs, and field effect transistors, in particular the MOSFET and the JFET. So we will be covering design, analysis, and simulation of diode and transistor analog electronic circuits, including amplifiers. So notice this is an analog circuit class, not a digital circuit class. And then, of course, we have a laboratory, and the activities will provide hands-on experience with all of the lecture topics. For example, building, measuring, simulating, testing, debugging, all of the electronic devices and circuits. I'm assuming you've all taken or are currently taking EE280. That's the introductory circuit analysis class. That's absolutely necessary in order to do well in this course. So the style of the course and the methodology that how we're going to approach this is to begin by learning the fundamental properties and physics of semiconductor materials. And we're going to focus on silicon, since that's the most important semiconductor material. So we will first learn the physics of solid-state semiconductor devices. Again, those devices are the diode, the bipolar junction transistor, the field effect transistors, the MOSFET and the JFET. And once we study the device physics of each of these devices, we will develop device models, which are basically mathematical equations that describe the device's behavior. For example, the current voltage behavior of a particular device. And we'll be looking at different regions of operation, the DC, direct current region, AC small signal, and then at the end of the course, we'll spend some time looking at high frequency models for all of these devices and circuits. So once we sort of learn how a device works, we start working on the circuits, and it's a sort of a three-prong strategy here. The first thing we're going to always do is predict the circuit behavior using the models in the theory. So these are hand calculations where we actually apply the device models and predict what the circuit's going to do. Then we're going to simulate the circuit using computer simulation software called LT-SPICE. And then finally, and arguably the most important one, is we're actually going to measure the circuit in the lab with hands-on measurements. So these steps here we will repeat over and over for each of the devices up here as we go through the semester. This is a weekly course schedule. I won't read through it in detail, but basically this is showing the 15 weeks of the semester here, and these are the topics that we're going to go through, and the chapter from the textbook. And again, this is the 8th edition chapter. It could be slightly different. If you get an earlier edition of the textbook, just be careful. Some of these chapter numbers may have changed over the years. But we're basically covering about 7 of the chapters in the textbook, and we're not particularly going in order. We're going to skip around a little bit, which makes more sense for this course. Course grading, there are 4 different components to the course, and they are equally weighted, and those components are homework, laboratory activities and reports, a midterm exam, and a final exam. And all of these are explained in more details in the syllabus. This is a detailed daily schedule for what we're going to be doing on each day of the course. And so this schedule is posted not only here, but it's posted in the lecture notes. It's also posted in the syllabus for the course. And basically this table here shows the day, this is day 1 basically through day 29 at the end of the semester. We're either on Monday or Wednesday, day of the week, and here's the actual calendar date. Here's the chapter from which we're going to be working from, and this column here is the lecture topic, and the last column is the laboratory activity for that particular lecture topic. And you'll notice that the lecture and the laboratory are going to be held on each day Monday and Wednesday, and I'll explain that shortly. But this is, I use this to keep track of what we're going to be covering, and you can do the same. You'll also notice our midterm exam and final exam are shown in that schedule. So this is an important change and note that I wanted to highlight and make sure you understand. This is a little bit different than what your university course schedule says. Your university course schedule says that on Monday we have lecture and on Wednesday we have laboratory. There's some problems with that. Trying to do a 3-hour lecture is extremely difficult, not only for the instructor, but it's very difficult for you as a student to try to listen to a 3-hour long lecture. And so what we're going to do is we're going to meet, every Monday and Wednesday from 12:30 to 3:20 in our classroom, VEP 5109. But we're going to break up the 3 hours such that the first part of the session, from 12:30 to roughly 1:45, we will lecture on some topic. Then we'll take a short break for 10 or 15 minutes. This is when you can go get some food, you can, get some water, go to the bathroom, all that stuff, kind of get your mind refreshed. And then we'll come back in, and the second half of each session, this is on both Monday and Wednesday, from roughly 2 o'clock till the end of our session, that's when we will do lab activities. And the lab activities are almost always based on what we lecture on earlier in the session. So there's sort of a nice flow here. You're going to see it in lecture first, and then you're going to come back and you're going to work on it that same day. So this type of schedule has worked out very well. I've taught this course several times now, and it seems to work out really well for both myself as an instructor and especially for you guys, for the students. And these times will vary. Some of the lectures are going to be, a bit longer and shorter than others. So, but I have, specific breaking points where we'll take a break and then get to work on the lab. One of the things that you're going to learn in here is the LT-SPICE simulation software. And I think maybe you've already had an introduction to this in EE280. I'm not really sure. I'm going to assume that you've never seen LT-SPICE before, and just start from the basics and build on that. If you've already used LT-SPICE, that's great. It'll just be easier for you to pick it up and learn some of the more advanced techniques. So LT-SPICE is an acronym for Linear Technology Simulation Program with Integrated Circuit Emphasis. It was software designed by originally Analog Devices, which is now called Linear Technologies. And this is open source freeware. It was originally developed back at Cal Berkeley in the 1970s. So it has been around for a long time, almost 50 years now. It's pretty much an industry standard. All electrical engineers, use LT-SPICE or have used it at some point in their career or school. So we have LT-SPICE loaded on our Dell laptops that are in the classroom. So they will be available, for when we're using LT-SPICE during our lab sessions and so forth. I highly recommend, though, that you download LT-SPICE at home on your computer. And you can Google LT-SPICE download and get it directly from the source company. It's freeware. It doesn't cost anything. If you are running a PC, it runs great because it was sort of designed for a PC. If you use a Mac, I'm not a Mac guy myself, but a lot of the students are. There are a few bugs and quirks with Mac, with running LT-SPICE on Macs, but the students seem to figure that out, and you can ask each other for some help on that if you need it. But anyway, yes, I would highly recommend you get LT-SPICE on your home computer. It's good to use for even checking your homework solutions and things like that. It's just a very handy circuit simulation software to use. So one of the important portions of this course, of course, is the laboratory. And so we have a a requirement that you know how to use the equipment in the lab. And so it's assumed that you've been trained and learned how to use this equipment in EE280. We're using obviously the same laboratory, the same set of equipment. So if you took 280 here at Cal State San Marcos, you should be fine. But however, we're asking that all students come in and attend an open lab session for training verification and get signed off. And this will occur during the first 2 weeks of the class. So once we have an open lab schedule, you can come in and it should just take a few minutes to get checked off on the equipment. And if you're rusty on the equipment, don't feel ashamed or anything. That's why our instructing assistants are there to help you. They will refresh your memory. And the goal here is just to make sure that, going into the first lab, you know how to use all the equipment so that you won't, damage any of the equipment. And also you want to make sure you obviously get good measurements and so forth. So again, you'll come in on your own time during the open lab sessions and meet with one of the lab assistants, and they will step you through a process to get checked off for the lab equipment. This is a list of the equipment that we're going to use. Again, this is all the same equipment that you used in 280. So we have one of the nice things about this course and our program here at Cal State San Marcos is we have an open lab schedule. And basically what this is a couple days during the week, the lab will be open for students to come in from this class and from other classes too. If you're in 280 or 303 or whatever, you can come in and work in the lab. So our student lab assistants right now are, as I mentioned, Jonathan Nunez and Christopher Lee. And so they will be hosting these sessions. I will not be there for these sessions. But you can come in and complete any unfinished lab activities, and you can make up any missed lab sessions. For example, if you were sick, like I am right now, or if you have to go travel, some students go to conferences and things like that, you still have to make up that lab. You don't get a freebie where, if you miss a lab, you don't have to do it. So if you miss a lab, it's your responsibility to come in on your own time during open lab and complete the lab. And also, as I mentioned on the last slide, the open lab is where you're going to be verified your training on the lab equipment, get checked off during the first couple of weeks. And we'll also teach you how to solder. It's a real quick lesson, but this is something that's good that every electrical engineer should know how to do. And so we'll set up some soldering stations during one or more of the open labs, and you can come in and learn how to solder. Right now, the open lab schedule is Monday afternoon after our class, so that would be at 3:30. And also Friday morning from 9 to 12. This schedule may change. It depends on the availability of the lab and the availability of our student lab assistants. So I will keep you posted on the open lab schedule, and that we'll post it up on the door or on the front of the room so that you can see that. One of the other highly recommended things for the laboratory part is to get a lab notebook. So just a spiral notebook is usually sufficient. One with graph paper in it is even better, so you can sketch graphs and so forth. But make sure you bring a pencil with an eraser to lab every day. And the lab notebook's an important tool, and you can use it to document your lab experiments, your data analysis, your results, and your conclusions. It'll help you write your more formal lab report, which you're going to hand in. So on Canvas, I posted a document called Lab Notebook Guidelines. It's got 10 tips for a good lab notebook. One note here is that I do not collect or inspect or grade your lab notebook. It's for your own personal use, and I would just highly recommend getting used to using a lab notebook. You'll be using one almost certainly when you're in the industry working as an engineer. So it's a good habit to get into now to document all of your work and experiments. Speaking of the lab reports and so forth, One of the other neat features of this class is that you're going to be writing and submitting your lab reports in IEEE format. And IEEE format's an industry standard way to publish papers. And so your lab reports are going to look very professional, just like something you would see in a journal, in a scientific engineering journal. So on Canvas, there is an IEEE template in Word, and you can download and make a copy of that template and then just edit it. Just change all the words and the diagrams and so forth. So this will be, if you've never used IEEE format before, there's always a learning curve with something like this. It's very picky, the rules and so forth. You'll read that on the template, what the rules are for, figures, and there's an abstract and things like that. But as we go through the semester, your lab reports, will get better and better because you'll get more and more used to this type of format. Also, make sure you bring a USB flash drive, a thumb drive to class. Any capacity is good, even a 16 gigabit capacity, which you can get for about $7 on Amazon. So you probably already have one of these, but you'll absolutely need it. Bring it with you to class. You can leave it in your lab kit, but you probably want to take it home with you because you're going to be using it to capture screenshots from the oscilloscope, from LT spice schematics, and so forth. And you're going to use those screenshots and put them into your lab reports. You're going to put them on this thumb drive. So make sure you get one of those. Last slide here, just let me go real quickly through some laboratory guidelines. So attendance is mandatory. So that means you need to be in class every day on Monday and Wednesday, because remember, we have lab every day on Monday and Wednesday. So if you miss a session, which sometimes happens, right? You get sick or you have to go on travel or whatever, you have to make it up during one of the open lab sessions that we talked about. Now, one of the great benefits of this program here at Cal State San Marcos is that our laboratory is equipped with over 30 stations. So we have enough lab stations so that each of you can work at your own lab station. So you're going to have your own set of equipment to use. You won't have to share it. And this is really important because it forces you to learn how to use the equipment on your own and do all the debugging and so forth. So it'll really sort of empower you to be in control of your own work. However, I would like to encourage sort of a culture of collaboration and cooperation amongst students and instructors. So you're encouraged to ask other students and or instructors for any help, assistance, or questions and so forth. So please feel free to compare and discuss your results with others. You don't have to just sit in your seat. You can get up and move around the classroom. Go ask your buddy on the other side of the classroom what their results look like, especially if something looks strange. And you can work together to solve problems and so forth. So this is, it makes for a nice sort of informal atmosphere, and this will, give you a greater chance of success, and it'll keep the morale in the class higher with this type of culture. So professional conduct is expected. You've heard all this before, but no cell phones, headphones, texting, social media, etc. during lecture and lab. No food or drink on the lab tables. This is a safety issue. Obviously, we have electrical equipment. So keep water bottles on the floor, and you can eat outside during break. I will be doing the same thing when we take a break during class every day. Also, you'll be given a lab manual. We'll distribute those the first week in class or maybe the second week. Bring it to class every day. It's yours to keep. You don't have to pay for it, but don't lose it. If you do lose it, you'll have to print out your own copies from Canvas. The lab manual is in electronic form as well on Canvas. So that is it for this, you guys. Thank you for your patience. And again, I'm sorry we're not doing this in person, but I will get back to class as soon as I can, and I look forward to meeting you there. Take care. Goodbye.